Question 1. In how many ways can the letters of the word capitalization be arranged if repetition is not allowed? Correct answer is option B. The word capitalization contains 14 letters with some repeated letters. Now let us consider repeated letters. Repeated letters are identical elements in a set, and their arrangements must be corrected by dividing by factorial of their frequencies to avoid overcounting. Count the frequency of each letter. A equals 3, I equals 3, T equals 2, and all others occur once. Total number of letters equals 14. The number of distinct arrangements of letters is given by the formula for permutations with repetition. Let us examine permutation with repetition. Permutation with repetition is defined as the arrangement of n objects where some objects are identical, given by n factorial divided by the factorial of identical object counts. Thus, number of arrangements equals 14 factorial divided by 3 factorial times 3 factorial times 2 factorial. This matches option 2. Question 2. In how many ways can the word adjustment be arranged such that all the vowels come together? Correct answer is option B. The word adjustment contains 10 letters with vowels A, U, E, 3 vowels, and 7 consonants. Now let us consider vowels. Vowels are letters A, E, I, O, U, that represent open sounds in speech, and in combinatorics they are often grouped when a condition requires them to stay together. Since all vowels must come together, treat the group AUE as a single unit. Now total units equals 7 consonants plus 1 vowel group equals 8 units. These 8 units can be arranged in 8 factorial ways. Let us examine permutation. Permutation is defined as the arrangement of objects in a specific order, where the number of arrangements of n distinct objects is n factorial. Within the vowel group, the 3 vowels can be arranged among themselves in 3 factorial ways. Total number of arrangements equals 8 factorial times 3 factorial equals 8 factorial times 6. Thus, the correct answer is 6 times 8 factorial. Question 3. How many words with or without meaning can be formed from all the letters of the word cadet without repetition? Correct answer is option A. The word cadet contains 5 distinct letters. Now let us consider distinct letters. Distinct letters are different elements with no repetition, so each letter is unique and contributes independently to arrangements. All letters are different, so no repetition correction is required. The number of ways to arrange 5 different letters is given by factorial. Thus, total arrangements equals 5 factorial equals 120. Hence, the correct answer is 120. Question 4. How many words starting with letter D can be formed by taking all letters from the word Delhi such that the letters are not repeated? Correct answer is the word Delhi contains 5 distinct letters, and the word must start with D. Now let us consider fixed position. A fixed position means one specific place in an arrangement is already occupied by a particular element, reducing the number of positions available for permutation. Fix D in the first position. The remaining letters are E, L, H, I. These four remaining distinct letters can be arranged in the remaining four positions. Let us examine permutation. Permutation is defined as the number of ways to arrange n distinct objects in order, given by n factorial. Number of arrangements equals 4 factorial equals 24. Hence, the total number of words starting with D is 24. Question 5. In how many ways can the letters of the word signature be arranged such that all the vowels come together? Correct answer is option A. The word signature contains 9 distinct letters with vowels I, O, U, E, 4 vowels, and 5 consonants. Now let us consider vowels. Vowels are letters O, E, I, O, U, that represent open sound elements, and in combinatorics they can be grouped when required to stay together. Since all vowels must come together, treat the 4 vowels as one single unit. Now total units equals 5 consonants plus 1 vowel group equals 6 units. These 6 units can be arranged in 6 factorial ways. The 4 vowels within the group can be arranged among themselves in 4 factorial ways. Total number of arrangements equals 6 factorial times 4 factorial. Hence, the correct answer is 6 factorial times 4 factorial. Question 6. If binum 158 plus binum 157 equals binum A, then the values of n and r are. Correct answer is option B. The given expression involves binomial coefficients. Now let us consider binomial coefficient. Binomial coefficient binum A represents the number of ways to choose R objects from n distinct objects without considering order. Use the identity, binum A plus binum A minus 1 equals binum plus 1R. Let us examine Pascal identity. Pascal identity states that the sum of 2 consecutive binomial coefficients is equal to the next row coefficient, i.e., binum A plus binum A minus 1 equals binum plus 1R. Here, binum 158 plus binum 157 equals binum 168. Comparing with binum A, we get n equals 16 and r equals 8. Hence, the correct answer is 16 and 8. Question 7. If binum 20n plus 2 equals binum 20n minus 2, then what is the value of n? Correct answer is option B. The given expression involves binomial coefficients with equal values. Now let us consider symmetry property. Symmetry property of binomial coefficients states that binum A equals binum n, which means selecting R objects is equivalent to leaving nr objects. Thus, equate the lower terms using symmetry, n plus 2 equals 20 minus n minus 2. Let us examine equating indices. Equating indices means setting the lower terms equal based on identity conditions to solve for the unknown variable. Simplifying, n plus 2 equals 22 minus n. Thus, 2n equals 20. Hence, n equals 10. Therefore, the correct answer is 10. Question 8. Evaluate C, n, r, plus 2 column, n, r minus 1, plus C, n, r minus 2, equals. Correct answer is option B. The expression involves binomial coefficients that can be simplified using identities. Now let us consider binomial identity. A binomial identity is an algebraic relation involving binomial coefficients that helps simplify combinations using standard formulas. Group the terms as C, nr, plus C, nr minus 1, plus C, nr minus 1, plus C, nr minus 2. Using Pascal identity, C, nr, plus C, nr minus 1, equals C, n plus 1r. Similarly, C, nr minus 1, plus C, nr minus 2, equals C, n plus 1r minus 1. Let us examine Pascal identity. Pascal identity states that C, nr, plus C, nr minus 1, equals C, n plus 1r, which relates consecutive. Thus, expression becomes C, n plus 1r, plus C, n plus 1r minus 1. Again applying Pascal identity, C, n plus 1r, plus C, n plus 1r minus 1, equals C, n plus 2r. Hence, the final result is C, n plus 2r. Question 9. Find n if n plus 2 factorial equals 60 times n minus 1 factorial. Correct answer is expand the factorial expression using definition. Now let us consider factorial. Factorial is defined as the product of all positive integers up to n, given by n factorial equals n times n1 time. Thus, n plus 2 factorial equals n plus 2, n plus 1, n minus 1 factorial. Substitute into the equation, n plus 2, n plus 1, n minus 1 factorial equals 60 n minus 1 factorial. Let us examine cancellation. Cancellation means removing common non-zero factors from both sides of an equation to simplify the expression. Cancel n minus 1 factorial from both sides. We get n plus 1, n plus 2, equals 60. Checking integer values, 3 times 4 times 5 equals 60. Thus, n equals 3. Hence, the correct answer is 3. Question 10. If to the power 2n 3p equals 100 times to the power np2, then find the value of n. Correct answer is option. Use the definition of permutation for both terms. Now let us consider permutation. Permutation is defined as the number of ways of arranging R objects out of n distinct objects, given by to the power npr equals n factorial divided by nr factorial. Thus, to the power 2n 3p equals 2n, 2n minus 1, 2n minus 2, and to the power np2 equals n minus 1. Substitute into the equation, 2n, 2n minus 1, 2n minus 2, equals 100. n-1. Let us examine algebraic simplification. Algebraic simplification involves reducing an equation by cancelling common factors and rearranging terms to obtain a solvable form. Simplify left side, 2n minus 2 equals 4n, n-1, so equation becomes 4n, n-1, 2n minus 1, equals 100n, n-1. Cancel n-1, from both sides. We get 4, 2n minus 1, equals 100. Thus, 2n minus 1 equals 25. So, 2n equals 26, right arrow n equals 13. Hence, the correct answer is 13. Question 11. The number of ways in which 5 boys and 4 girls sit around a table such that all the boys sit together is. Correct answer is option. Treat all 5 boys as a single group so that they sit together. Now let us consider grouping. Grouping means combining multiple elements into a single unit when they must stay together in an arrangement. Now total units equals 4 girls plus 1 group of boys equals 5 units. These 5 units are arranged around a circular table. Let us examine circular permutation. Circular permutation is defined as the number of ways to arrange n objects around a circle, given by n1 factorial due to rotational symmetry. Thus, number of ways to arrange 5 units equals 5 minus 1 factorial equals 4 factorial. The 5 boys within the group can be arranged among themselves in 5 factorial ways. Total arrangements equals 4 factorial times 5 factorial. Hence, the correct answer is 4 factorial times 5 factorial. Question 12. What is the number of ways in which 5 boys and 4 girls sit around a table such that all the girls sit together? Correct answer is option A. Treat all 4 girls as a single group so that they sit together. Now let us consider grouping. Grouping means combining multiple elements into one unit when they are required to remain together in an arrangement. Now total units equals 5 boys plus 1 group of girls equals 6 units. These 6 units are arranged around a circular table. Let us examine circular permutation. Circular permutation is defined as the number of ways to arrange n objects in a circle, given by n1 factorial due to rotational equivalence. Thus, number of ways to arrange 6 units equals 6 minus 1 factorial equals 5 factorial. The 4 girls within the group can be arranged among themselves in 4 factorial ways. Total arrangements equals 5 factorial times 4 factorial. Hence, the correct answer is 5 factorial times 4 factorial. Question 13. In how many ways can the letters of the word corporation be arranged such that all the vowels come together? Correct answer is option A. The word corporation contains 11 letters with repetitions, O equals 3, R equals 2, and vowels are O, I, 5 vowels. Now let us consider repeated letters. Repeated letters are identical elements in a set, and their permutations are counted by dividing factorial by the factorial of their frequencies. Group all vowels, o, I, as one unit. Now total units equals 6 consonants plus 1 vowel group equals 7 units. Among consonants, R is repeated twice. Let us examine permutation with repetition. Permutation with repetition is defined as the number of arrangements of n objects where identical objects are present, given by n factorial divided by factorial of repetitions. Thus, arrangements of 7 units equals 7 factorial divided by 2 factorial. Now arrange vowels. 5 vowels with a repeated 3 times tends to 5 factorial divided by 3 factorial. Total arrangements equals 7 factorial divided by 2 factorial times 5 factorial divided by 3 factorial. Simplifying, 5040 divided by 2 times 120 divided by 6 equals 2520 times 20 equals 50,400. Hence, the correct answer is 50,400. Question 14. How many different 5-digit numbers can be formed using the digits 0, 2, 4, 6, 8 when repetition is not allowed? Correct answer is option A. The given digits are 0, 2, 4, 6, 8 and repetition is not allowed. Now let us consider restriction. Restriction means a condition imposed on arrangements, such as certain digits not allowed in specific positions, like leading digit cannot be 0. For a 5-digit number, the first digit cannot be 0. Thus, first digit can be chosen from 2, 4, 6, 8 tends to 4 choices. After fixing the first digit, remaining 4 digits, including 0, can be arranged in remaining 4 positions. Let us examine permutation. Permutation is defined as the arrangement of distinct objects in order, given by n factorial when all objects are used. Thus, remaining arrangements equals 4 factorial equals 24. Total numbers equals 4 times 4 factorial equals 4 times 24 equals 96. Hence, the correct answer is 96. Question 15. How many different valid 3-digit even numbers can be formed using the digits 0, 1, 2, 3, 4, 5, 6 without repetition? Correct answer is option B. A valid 3-digit even number must have its unit digit as an even number. Now let us consider even number. An even number is an integer divisible by 2, so its last digit must be 0, 2, 4, or 6. Possible unit digits, 0, 2, 4, 6, 4 cases. Case 1. Unit digit equals 0. Remaining digits equals 1, 2, 3, 4, 5, 6 tens to hundreds place has 6 choices, excluding 0. Tens place has 5 choices tens to total equals 6 times 5 equals 30. Case 2. Unit digit equals 2, 4, or 6. Remaining digits include 0. Let us examine restriction. Restriction means certain positions have limitations, such as the first digit of a number cannot be 0. For each case, 2, 4, 6 hundredths place has 5 choices, excluding 0 and used unit digit, tens place has 5 choices tens to total equals 5 times 5 equals 25 each. Total for these 3 cases equals 3 times 25 equals 75. Total numbers equals 30 plus 75 equals 105. Hence, the correct answer is 105. Question 16. How many different valid numbers greater than 800 and less than 4000 can be formed using the digits 0, 1, 2, 4, 5, 7, 8, 9 without repetition? Correct answer is option. The required numbers lie between 800 and 4000, so they can be either 3-digit or 4-digit numbers. Now let us consider case division. Case division is a method of counting where the problem is divided into mutually exclusive cases and each case is solved separately. Case 1. 3-digit numbers greater than 800. Hundreds digit can be 8 or 9 tens to 2 choices. Remaining digits, choose tens and units from remaining 7 and 6 digits tens to total equals 2 times 7 times 6 equals 84. Case 2. 4-digit numbers less than 4000. Thousands digit can be 1 or 2 tens to 2 choices. Let us examine permutation. Permutation is defined as the number of ways to arrange distinct objects in order, considering position. Remaining 3 places can be filled from remaining 7, 6, and 5 digits respectively. Thus, total equals 2 times 7 times 6 times 5 equals 420. Total valid numbers equals 84 plus 420 equals 504. Hence, the correct answer is 504. Question 17. How many 3-digit numbers can be formed such that digit 1 is never to the immediate right of digit 2? Correct answer is option D. Total number of 3-digit numbers formed using digits 0, 9. Now let us consider total counting. Total counting refers to counting all possible outcomes without any restriction, using multiplication principle. Hundreds place, 1 9 tens to 9 choices, tens place, 0 9 tens to 10 choices, units place, 0 9 tens to 10 choices. Total numbers equals 9 times 10 equals 900. Now subtract numbers where digit 1 is immediately to the right of digit 2, i.e., 21 occurs. Let us examine complementary counting. Complementary counting is a method where required outcomes are obtained by subtracting unwanted cases from total outcomes. Case 1. 21 in tens and units place tends to form, _21 tends to hundreds place has 9 choices tends to total equals 9. Case 2. 21 in hundreds and tens place tends to form, 21 tends to units place has 10 choices tends to total equals 10. Total unwanted equals 9 plus 10 equals 19. Required numbers equals 900, 19 equals 881. Hence, the correct answer is 881. Question 18. How many 4-digit natural numbers are there such that all of the digits are odd? Correct answer is option A. Only odd digits are allowed. 1, 3, 5, 7, 9. Now let us consider odd digits. Odd digits are integers not divisible by 2, namely 1, 3, 5, 7. Each of the 4 positions, thousands, hundreds, tens, units, can be filled using these 5 digits. Let us examine multiplication principle. Multiplication principle states that if one event can occur in m ways and another in n ways, then total ways equals m times n. Thousands place has 5 choices, no restriction since 0 is not involved. Similarly, each of the remaining 3 places also has 5 choices. Total numbers equals 5 times 5 times 5 times 5 equals 5 to the power 4 equals 625. Hence, the correct answer is 625. Question 19. How many 4-digit numbers divisible by 5 can be formed using the digits 0, 2, 5, 6, 9, without repetition? Correct answer is option D. A number divisible by 5 must end with 0 or 5. Now let us consider divisibility rule. A number is divisible by 5 if and only if its last digit is 0 or 5. Case 1, unit digit equals 0. Remaining digits equals 2, 5, 6, 9. Thousands place cannot be 0, so 4 choices. Remaining 3 places can be filled in 3 factorial equals 6 ways. Total equals 4 times 6 equals 24. Case 2, unit digit equals 5. Let us examine permutation. Permutation is defined as the number of ways to arrange distinct objects in order, given by n factorial when all are used. Remaining digits equals 0, 2, 6, 9. Thousands place cannot be 0 tends to 3 choices, 2, 6, 9. Remaining 3 places can be arranged in 3 factorial equals 6 ways. Total equals 3 times 6 equals 18. Total numbers equals 24 plus 18 equals 42. Hence, the correct answer is 42. Question 20. If binom plus 1 r plus 1, binom a, binom minus 1 r minus 1 equals 11, 6, 3, then find the value of nr. Correct answer is option D. Write each binomial coefficient using factorial definition. Now let us consider binomial coefficient. Binomial coefficient binom A represents the number of ways to choose r objects from n objects, given by n factorial divided by r factorial r factorial. Use ratios. Binom plus 1 divided by r plus 1 binom A equals n plus 1 divided by r plus 1 and binom divided by a binom minus 1 r minus 1 equals n divided by r. Let us examine ratio simplification. Ratio simplification involves reducing expressions by cancelling common factorial terms to obtain simple algebraic relations. Thus, n plus 1 divided by r plus 1 equals 11 divided by 6 and n divided by r equals 6 divided by 3 equals 2. From n divided by r equals 2, we get n equals 2r. Substitute into first equation, 2r plus 1 divided by r plus 1 equals 11 divided by 6. Cross multiply, 6, 2r plus 1, equals 11, r plus 1. Simplify, 12r plus 6 equals 11r plus 11 right arrow r equals 5. Thus, n equals 2r equals 10. Hence, NR equals 10 times 5 equals 50.